Oh, I see. Okay, I got two first. Test, test. Can everyone hear me? No, not really. I gotta speak even louder. Uh, is it possible just to turn the volume up just a little bit more? Sorry about that. Test, 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 test. Okay, perfect. All right, everyone, take your seats or stand if that's what you prefer. Um, Good evening. My name is Savannah Harlan, and today I'm going to be giving my presentation on synthetic data and its effects on the power structure um, that as we're going to see in like the next while. And I am a researcher here with Trajectory Labs. We're just like a co-working space for people who are working um, in the AI safety field. And if you want to learn more about us, reach out to Juliana or any one of the other members here at the end, and would be more than happy to walk you through it. So the first thing is, I guess we should kind of get over like what is synthetic data, right? Because there's regular data, which is the kind of thing that is produced sort of organically by us over time. So, you know, Facebook tracks a bunch of stats like how long you watch a certain post, how many people click on an ad, and those are all examples of like natural data, let's call it. Synthetic data is what happens when you sort of feed data into a generative model and use it to try and answer counterfactuals or to make predictions for things that have not happened yet. So just one quick example, you know, this is an example of like regular data stats that might be tracked by a company. But if instead you wanted to know, you know, how many sales will we make in September, or how many days of, you know, how many 4+ consecutive days of 30-degree or higher weather are we going to see over the next 10 years? Those are the kinds of questions that you would have to answer by using a model to sort of simulate the future. And you would kind of call that data synthetic data. Um, so this is kind of like what the synthetic data generation process looks like. And the key thing to note here is that this is really just like a graph of how you train a normal generative model. And that's one of the main things, is that to produce synthetic data, we need to already have gotten to the current point in history that we are at. So synthetic data can only be produced once we've already had the technology to build generative models. This brings us to the other question, though, of like, why would you want to use synthetic data, right? And the thing is that synthetic data is generated by a bunch of different actors, and all of these different actors may have different reasons for wanting to use synthetic data. So in the context of an advertising company, they may want to understand, well, we don't really operate in this country right now, but if we were to operate in this country, how many people could we expect to reach, for instance? For researchers that are doing like weather modeling, for instance, they might want to know, okay, we only have data from like 10 or so weather stations in the country, and they're all in the east end of the country. But we want to know like what kind of data would we expect to see if we had the investment to build weather stations in the rest of the country, for instance. But there's kind of just three main practical reasons for why we would want to use synthetic data, and they're kind of all listed there. The first one is that it's possible. The second is that it's convenient. And the third one is that it's going to become more instrumental as time goes on. So the historical context is this. Early generative models were really bad at producing natural seeming data. You can kind of see this if you have a conversation with like GPT-2, for instance. So because of this, like early in machine learning, most of the focus was really on classification tasks. And that's simply because classification in general, the problem structure is a lot simpler. And what makes synthetic data possible is generative models. And what makes generative models possible, there's really three main things that have sort of happened. And these are all within, say, like the last 10-ish years or so. The first one is just the move towards big data, right? The second is improvements in computation power. And this largely comes as like a result of us realizing that we could use GPUs to do a lot of the computations in parallel. But this insight also kind of depends on architectural innovations, right? So just having access to GPUs that can do computations in parallel doesn't help if all of your models are built on architectures like recurrent neural networks that aren't as amenable to parallelization. And you can kind of ignore all of this boring math, but the main idea is that a classifier model, just has to sort of segment the data space into disjoint regions. Whereas when you are building a generative model, it has to reconstruct like the data distribution. And that's a fundamentally harder task. So I'm just trying to provide like a bit of intuition here as to why classification came first. Are there any questions so far? No? Okay. So the second context is the legal and economic context. So this is what made synthetic data convenient, right? The first one is what made it possible, and that's just the same things that made generative AI possible is what made synthetic data possible. But now we're talking about like what makes synthetic data convenient. And there's kind of a lot of things here, right? The first one is that training data has become really expensive because the first round of building these models, they kind of happened subtly or in the dark, right? No one knew that all of our data was being scraped to build these models. But now that platforms and websites do, they've started charging for access to this data, So if you want to get Reddit's data, for instance, you're gonna have to sign like a data licensing deal. But also training data has just become less freely available in general. So a ton of websites have like disabled web crawlers, for instance. The ones that come to mind are like the New York Times and the Wall Street Journal. And this slide was just taken from one of my other presentations. You can just sort of skip over it. But all I wanted to show you was that if anyone remembers, in 2023, Reddit started charging for API calls, right? And prior to that point, it was virtually free. And when this happened, there was kind of like a huge outcry. But this was like fairly directly linked to the fact that Reddit realized that all of these developers were training off their scraped data. Oh. I'm just going to give you guys a second to read the slide while I drink water. So companies have also started suing AI developers over the use of their intellectual property. And all of these things make it a lot harder for people to train models as they did pre-2022. And these are just some examples or headlines of the kind of difficulties that developers now face in trying to train their models on natural data scraped from the internet. Yes. So, put another way, the benefits of using synthetic data is that since you made it yourself, first, synthetic data is cheaper to use, right? You don't have to pay any licensing fees, you don't have to negotiate with anyone for data rights, you don't have to pay for API calls to actually get that data. And it's also safer to use for that same reason. But it's also faster to use because synthetic data is generated by a model, right? Not humans. And this turns out to actually be maybe like the biggest point about synthetic data, which is that natural data can only be generated organically over time. So, you know, to get like a year's worth of data about human browsing habits on Facebook, the amount of time that takes is a year. Like that part really cannot be changed. But if the data is being generated organically and the model knows what like realistic data samples look like, you can kind of query the model to generate this data at scale nearly instantaneously, right? And the next thing that makes it convenient is the fact that we're kind of running out of data. So for models to like improve and learn, they obviously need data, but it seems as though like there's some good arguments and research that suggest that we've already exhausted kind of most of the publicly available data on the web. And if that's true, there's only two ways to go about it. You either wait for us to generate more data organically, or, you know, you find synthetic alternatives. So just kind of laying it out here, these are like the three options facing developers that I see. And if anyone can think of any more, or, you know, if you feel that these are incorrect, please let me know. Before I move on, are there any questions so far? So I'm going to talk now about the last instrumental or functional context, which is we're using synthetic data also because it's kind of necessary. And to kind of understand this, I guess, think about what you can do by giving a model more data. The amount of data that we have right now, sorry, let me phrase this another way. If you're trying to teach a model a new language, but there just isn't that much data available on that language because it's not a very widely spoken language, the model is kind of stuck, right? But if you can use machine translation techniques to generate synthetic sentence pairs to feed into that model, now, for instance, the fact that the model didn't originally have enough data to learn Swahili is no longer an issue. And this is kind of where synthetic data becomes instrumental. It's when you lack the natural data to train a model, but you have enough data about some adjacent task that the model can use to glean or fill in the gaps for the information it doesn't have. Another good example is like computer vision. So imagine you're training a text-to-image model. If most of the pictures in the model's data set are like selfies taken from this angle or portraits taken from like a 3/4 angle, if you ask the model right, generate me an image of someone from the back. The model may struggle to do that just because it doesn't have enough of that kind of data in its data set. So a famous example that has been patched now was, people asking GPT-4 to generate an image of like a almost empty wine glass, and it wasn't able to do that. But synthetic data can also be used for more meaningful tasks, like reducing bias in medical data. The canonical example is like cancer imaging data. The majority of data in these data sets come from people who can actually afford preventative care. So that's mostly people from white and Asian populations in the West. But this just kind of means that classifier models who, for instance, have to detect tumors don't perform as well when it comes to patients with darker skin. And one of the things synthetic data can be used for in such a case is to generate plausible samples, right, of what benign and cancerous tumors would look like on people with darker skin. And you can sort of use this to make sure that the classifier model has seen a more representative sample. So this is just kind of like a toy example showing you what a data set, a medical data set might look like. And you can see like, the medical data set might really underrepresent people who are black and then severely overrepresent people who are white. And if you use synthetic data, you can kind of try and make sure that these numbers get back to something that is closer to the actual like population level proportions. So summing this part up, these are the 3 reasons why synthetic data is being used. And are there any questions so far? Yes? That's a great question. So we do get to that, but I guess the straightforward answer is that it improves the performance of the classifier models. I don't think it makes them perfect, but the assessment of efficacy is done relative to baseline, and the baseline is like a model that hasn't seen these like synthetic samples of tumors in people with like different skin colors, for instance. So there is an improvement, but I hear your point on like bias and whether like this may actually whether this properly like alleviates the problem of underrepresentation in medical data. So now I get to the point about how synthetic data transforms power and knowledge. And there's 3 points here, but before I get to them, I kind of just want to focus on one that I've already touched on slightly, which is, how does synthetic data affects the distribution of power on the internet? And the one that I can really think of, the one that seems very salient to me, is it feels as though synthetic data will replace the need for human content creators, or the need to compensate human content creators. Because you can kind of imagine if a model has seen all of the videos on YouTube, right? And they, the creators want to train the model furthermore to make it better at producing videos. If they now have their access to YouTube cut off, or they simply don't want to pay to license any of the data on YouTube or compensate the content creators, a developer can just sort of generate synthetic videos for their purposes. And so the concern is kind of this. As synthetic data becomes more prominent, will it reduce the incentive of AI developers to compensate people on the internet whose data they are training these models on? And I guess the real concern is that once you've built a generative model, it's kind of self-sustaining. Like you don't really need the original data you trained on anymore. And this may create a kind of scenario where in the future, companies that right now have to enter into data licensing agreements to legally obtain the data they use will simply see it as cheaper or more efficient not to do that at all. There is also one other thing though, which is I guess the diminishing marginal value of new data. So you can imagine a model before it's seen anything on Reddit. It kind of benefits a lot from seeing, like 1,000 Reddit posts and all the comments under it, because it learns about like human slang, the way people interact. But if you've already seen like 100,000 Reddit posts, how much does training on the 100,000th and first actually improve your model? And I ask these questions only because I think it's important to sort of think about how synthetic data is going to affect the socioeconomic considerations with regards to data licensing and data production. And what I fear, I guess, is that as synthetic data becomes more prominent, this really shifts power away from platforms, users, and websites that don't develop their own models. So this is kind of like what the generation process would look like once you've built the initial generative model. You really don't need the first part anymore, because you can just iteratively use the model you've trained to generate more and more synthetic data. So it's worth asking, like, will synthetic data kind of reduce the reliance on human activity? And will it create a situation where content creators and websites and platforms lose the bargaining power that they have right now over the developers? Because right now there's kind of a trade-off, right? Companies realize that AI developers were taking advantage of them in terms of training on their data for free. So now they're saying, well, we're going to block off your access to this data, and we're going to sue you if you use our data without permission. But if AI developers just generate all of this data synthetically, you can kind of see how this may not even factor in. So I just kind of want to talk about why this debate may be hard to resolve. From an information theory perspective, developers are just going to claim that their models don't steal, they learn. And mathematically speaking, this is kind of true, because when a model learns, what it does is learn structures. It doesn't memorize any specific piece of data. that data isn't stored anywhere in its weights. Like what it really learns is like a lossy, compressed representation of the data. And the rough mathematical intuition I guess I want to give is that the number of trainable parameters in a model sort of acts as a upper bound on how much the model can memorize. Um, and if you kind of want to get the mathematical argument that developers are likely to make as to why their models don't memorize or steal, this is going to be it. But obviously, this isn't very satisfactory because creators will continue to feel exploited, justifiably because their information was required to train at least the first generation of generative models. But now that that's been done, developers don't really need us. But developers can also argue that, from a technical perspective, these models really aren't stealing when they learn, or that learning is fundamentally different from stealing. Um, and I just think that if we are to solve issues like this from a policy perspective, it needs to incorporate both the fact that this is likely to have some kind of economic impact on society, but also the mathematical and epistemic realities that learning, at least in the way that models do them, is not akin to the way that we see or conceptualize stealing. Does anyone have any questions?
Like, what I don't get is, I thought there was inherent difficulties with synthetic data. Like, even when you're talking about synthetic generative video right now, you need a human doing it and like assessing whether this is good or not. Like, there's been no case of an LLM like a video generation model just spontaneously creating like a video that just went viral that we like resonate with as humans. There's always the human controlling everything. So like my understanding is that synthetic data is not there. Is that true or?
I think I would say it's true in the context that you are speaking about it, but I would also say that synthetic data is kind of sort of like different from synthetic content. And the difference isn't that large, but it's sort of functional. So, for instance, if I use ChatGPT to generate 1,000 pictures for fun, that's just like synthetic content, right? But if those images somehow make their way onto the internet, and then OpenAI unwittingly trains GPT-6 on all of those images, that's now synthetic data. So in regards to whether it could create a really good video, for instance, I think that there's really no reason why synthetic data cannot improve models to that point, and I would agree with what you said, which is just that it seems like a matter of time rather than technical feasibility. It will affect model performance. Um, the way I would kind of see it is this: like the lack of ground truth is certainly a problem. Like if you query a model to give you synthetic data about, say, um, the next year's worth of daily mean temperatures in a country, you you obviously you can't see into the future, right? So you're not going to know whether what it tells you is going to be accurate or not. Um, But with machine learning models, I guess the hope is that we feed them good enough data, and whatever outputs they give us, even if they seem implausible, we kind of use that to shift our own priors instead of saying, hey, this model is bad. So, if the model shows you that next year there's like 7 heat waves in a row, I guess the question is like, would you say that's an unreliable model? Or would you say, damn, this is interesting? Looks like next year is going to be really bad and we should start making preparations. Um, but you are right. The problem with synthetic data to an extent is that there is no kind of ground truth for comparison. You kind of just have to make a judgment on your own about how plausible the data is. Um,
This can also make progressively worse. If you take the weather, so it's predicting 2025 weather, which is great, let's say, and then you feed that, and that is used for predicting 2026, and it's now moved away from the truth because of the approximations already there. By 2030, it's completely useless, right?
yeah. Uh, so you make a really good point. Although I would say that the limitation you're talking about is more about all chaotic systems in general. So, you know, the the further in time you go from the current time step, the more things will diverge from initial conditions. And because it's a chaotic system, the way that things diverge, it's going to be unpredictable, but it's also going to blow up very quickly. So it's true, if you kind of use synthetic data to figure out what's going to happen for next year's weather, and then you use that again to figure out what's going to happen for the year after that. If there are issues in the model, those problems will compound. But I also think it's important to note that there's kind of like two sorts of uncertainty in statistics, right? The first one is epistemic uncertainty, which is uncertainty um, in the parameters. So maybe your model's not that great. Um, Maybe there's ways to improve it. Maybe there's features that are lacking that you should build in that would help make the model make better predictions. But the second kind of uncertainty is like aleatoric uncertainty, and that's like the uncertainty inherent in our world. So think about like a coin flip. You know, even if you have like a perfect understanding that the coin is fair and it's going to come up 50-50 heads and tails, that doesn't really tell you, like if I flip the coin next, is it going to come up heads or tails? Because the best your model can do is sort of tell you that's going to be a 50-50. So I would say that part of what you're talking about relates to that second type of uncertainty, aleatoric uncertainty, which is even if you built the best model, it's still a probabilistic process, at least as far as we know. Sorry.
If we were to stop training models on real data today and it was all synthetic data, then going forward, at the very least, it wouldn't be able to tell me things about the real world since the date it didn't happen. Unless, I suppose, you attach it to a tool that can search the internet and the data is available, but not in its training data, essentially. Do you consider that a problem for progress of model development, or is this just sort of a use case question in the end?
Um, I, I, I definitely don't know if I consider it a problem. Like, to some extent, that's just a limitation of the way models are built now. Like they have a specific cutoff date for when they stop training. Um, but also on a more philosophical level, you might say that's kind of the difference between a human and a model, which is that we never really go out of the training phase. Even right now when I'm speaking to you, like I'm still adjusting the weights in my head. Whereas, once a model has gone out of training, for the most part, its weights are frozen. And so I don't know if I see that as a problem, more just a fact of reality. But it's also something that could change in the future. Like we may not be far off from the day when we see models that continuously learn, that never exit that learning phase. But I feel like that comes with its own set of existential risks. By the way, am I blocking anyone? I realized I kind of just keep standing here. Like, should I be standing here instead? Here? Yeah, okay. Figured. Yes.
So like what you described, like using synthetic
I have suspicions, but maybe he can answer. Yes. Do you want to jump in here?
There are models that train more or less exclusively on data. So at Microsoft Research, there's a researcher called Sebastian Buback. He trained a series of models called Phi. Phi is more or less exclusively synthetic data. At the end of 2024, Sebastian Buback joined OpenAI, and with the latest release OpenAI's GPT-OSS model, um, the speculation is, his team mostly trained that on synthetic data, and you can try that model right now on lots of benchmarks, especially reasoning benchmarks. It does really well. It does very competitively, even though synthetic data. But on some more common sense data sets, so there's a data set called Simple QA, just basic everyday conversation, question and answering. It seems like GPT-OSS doesn't do that well. And anecdotally, it seems like in everyday usage, it seems to hallucinate a lot. But there are very good benchmarks that it performs well on. I know in the medical sector, when I was previously in school, I think there's lots of medical data where you have a shortage of patient data, and you generate synthetic data first when you initiate the weights to get the weights to be at a good place, and then you feed it the real data. It does improve over the baseline just using
Right. That's what I would suspect too. Um, but to answer your question more directly, no, we don't know because OpenAI has stopped being so open after GPT-2. So they don't really disclose a lot of things about their training process anymore. Um, but the last model card that I can remember reading, I think it was Llama 3, and that family of models, I remember Meta did start using like a significant amount of like synthetic data in their mixture, and I would expect it to only increase for the three reasons that I mentioned before. It being necessary, convenient, but also instrumental. Oh, sorry, ignore that one slide that was supposed to be taken out. So let's just talk about the limitations of synthetic data really quickly, because I've told you a lot about the things that it can do or it could do, but it might be worth asking, like, what about the things that it cannot do? So first, I want to kind of focus on, the discussion in the literature around its technical limitations, model collapse being one of the major ones. So model collapse is kind of like this idea that, you start out with your natural data set and it follows, let's say, like a Gaussian distribution. But if you ever look at a Gaussian, the majority of like the probability mass is like right in the center, and that's if you sort of take samples from the data set, that's kind of where most of your samples are likely to occur. And the idea behind model collapse is that if you train generative models successively on their own outputs over generations, you will tend to end up with models that perform worse on a range of tasks simply because they sort of lose information about the variance in their tails. Are there any questions about this? Perfect. So this is kind of an example of, just imagine this is like the original data set. And it doesn't really look very much like a bell curve, but you just kind of have to trust me on it. And then imagine taking a bunch of samples from this data set. Most of your samples are just going to come from here, right? Like that's just how probability works. So then you may end up with a synthetic data set that looks a bit more like this. And as you can see, the main thing is that you lose a lot of information about like the tail events. And this may not matter much, but over time, at least for your language generation models, it tends to result in stuff like a vocabulary that is more robotic, um, less varied, and just more like mechanical sounding outputs. But model collapse turns out to actually be like a kind of easy problem to solve. So the the paper by Sadiq and others in 2024 found that as long as you retain even like a small amount of natural data in the mixture, as low as 2%, that's enough to alleviate model collapse. And if that's true, it means that the majority of concerns that we have over models kind of like incestuously feeding on their own data and producing information to train future generations, it's a problem, but it's overblown. Now, I kind of just want to talk about synthetic data's role in the context of like advancing towards AGI very quickly. So AGI is typically thought of as like, the scaling recipe, and there's usually 3 pillars, but I've included a 4th one just for fun. And the first one is like, how big are your models? And we're already making bigger models, so that's not that important. More compute. We're obviously also pouring more money into compute. You can kind of see that just by looking at the investment trends in the United States, but also China, and the amount that they are pouring into building the infrastructure for the electrical needs of these data centers. Better architectures is another point, but it's not one that we can affect directly. That's kind of just like scientific progress. It happens at its own pace. So the bottleneck then is data, and that's why synthetic data kind of comes in. So just like kind of put very simply, if a large language model has already read all of the textbooks on math and physics, how do you make the model better? Like, you have it write more textbooks, right? But the problem here is that if we're using models to generate synthetic data to improve themselves, this data has to be like of a specific kind of quality. Like, it can't be trivial, but it also can't be too hard. So this touches on like, the philosophical limitations of synthetic data. So we want it to advance scientific research, and we hope that it can help us generate novel conceptual insights. But can it do that? Can generative models create meaningfully novel data? Can they ask questions that would challenge themselves? Does anyone have any thoughts on this? Do you think it's possible? Not possible?
I don't think they've come up with any breakthroughs so far, like math, or I think they did some protein stuff, but it's been few and far between.
No, that's a good point. The models haven't done anything groundbreaking yet. But my question was, is it possible that they do? So what do you think? Maybe?
Matrix multiplication problem where it reduced the number of operations by 1 or 2, which we never thought was possible.
Kind of touch on that point a bit. I think that is actually a very interesting point of like future research. Basically, it wasn't the model itself that figured out how to do the more efficient computation. It was the model helped in generating code that you could then verify the results of the code and then use that as a reward signal to get the model to generate better code in the future. study as an example of a task where it is possible to, in some sense, be creative. I don't necessarily think that it being done on that task necessarily means that it can be done on any task, but also, yeah, that's about it.
Yes.
I think I guess one data point would be this like 37 was it? Right? Like in Go, I believe, for one of the very first models was doing this super creative thing and certainly never saw on any training data, but it came up with this being super brilliant in this particular situation. I don't know if this generalizes really well to other tasks, but I wonder if you just throw so much compute at it that it thinks longer and harder about a particular issue than a human's lifetime, even if it's whatever Einstein's or something, then perhaps if you sort of consider creativity to be just a very novel combination of things that you've seen in the past and it's able to bring knowledge from different fields together, like I don't see why not.
Yeah. No. Those are all great points. I I definitely don't have the short-term memory to repeat them all, but those are all good instances of maybe preliminary evidence that models have the conceptual creativity to generate meaningful synthetic data. The the one thing I kind of want to like hone in on though is if you can imagine the difference as being um, answering a question with more and more creative answers, which is probably what models are already going to get better at. What we really want to see if they can do is whether they can come up with better questions to ask themselves, because that will really automate the process and sort of kick us off with regards to recursive self improvements, right? So like we can write harder and harder exams for these models, but ideally we want them to write harder exams themselves because we're lazy. And if the models get to that point, where they can ask a difficult exam question to themselves, that will be like the really meaningful breakthrough. Because a difficult exam question, if you think about it, is like it has to be hard enough that you don't know the answer right away. But you also have to know that it's solvable. So you can't just ask like an arbitrarily, like insanely hard question. Um, so this is kind of like why I would talk about novelty as being like constrained creativity. It's not just creative in the sense of, oh, I've never heard that before. Because on balance, like a model can say like any amount of gibberish and you would never have heard it before. And then that's like novel. But that's not going to improve the model in any meaningful way. Like if you're trying to get to AGI, the outputs need to be novel, but kind of like in a constrained creative way. So this, I guess, is like the philosophical argument against models being creative. Because the way that they learn is quite literally by learning about these statistical regularities and patterns in data. It's possible and plausible that this this very learning process itself is not able to create a model that can be like fundamentally creative or thought provoking, right? So like the whole way a language model is trained, for instance, is to like predict the next word, and in some sense, it learns to do this by predicting like what a human would say next. So you can kind of think of it as like its job is to say something that you would expect, and if that's true, then it's like how could it surprise us? Um, but to some extent, we already know this isn't true because models do surprise us, or at least I'm surprised when using them. I'm just gonna drink some water. So the counter argument is that if you're going to say that a model can't come up with new things because like it's constrained by the stuff it's seen before, humans are also constrained by the things we've seen before. Like a human cannot come up with a new color we've never seen. but this doesn't prevent us from making like scientific breakthroughs or mathematical breakthroughs. So you might argue that this is something that is true but doesn't make a difference. And then more deeply, you might kind of say that all like all progress happens iteratively, in that everything always builds on something before, and so maybe the models, the fact that they can only remix what they've seen is not that different from how humans come up with new ideas and information.
Isn't basically every scientific invention at some point, um, sorry, I lost my train of thought for a second there, but was it, so your point of the counter argument was that humans can't come up with new colors, like we can't just, like, no one ever came and just invented a new technology, and it's always like built up, right? Um, but isn't it true that sometimes this kind of does really happen, where sometimes maybe some chemist accidentally makes a new element that kind of happens? Like I feel like that doesn't always happen. It's not a rule of thumb that all inventions are always built on something else. Sometimes it is kind of like an accident or something.
That No, that's a good point. So Alex was just kind of saying that, the counter argument here might actually just be nonsense, right? Because sometimes we come up with things on accident. So we're not even trying to mix like A and B together. It's more like we spill a flask and then it creates like a new solution, and we're like, holy crap, this thing is fireproof now. All I would say there though is that for you to spill like the flask, you need to already have had a chemical there. That's kind of what I mean by like remixing. It's like, even if your goal was not to like remix these ideas, you know, the idea of like idea generation by accident still requires constituent pre-existing ideas, you know.
Some entirely new topic, which, let's just say, alien biology or something. I'm just gonna put that, right? We humans, we could probably figure out biology in general first, maybe figure out, okay, maybe there are cells and not based on carbon, but some other thing, and go from there. But an LLM has never seen anything in that category. I don't think you'll be able to even reason about that at all. Do you know what I mean?
Like you're saying, a large language model might not be able to reason about alien biology because
It can't. It's never seen anything remotely like that. Like a new
right.
color, a human could come up with a new color we've never seen before because we understand what colors are.
But how? Like how would you come up with a new color? Go on.
I look cyan, beige, and
Uh,
black.
All right, combine them for me. Go on.
0x14, 0x19, 0x FF. There we go.
All right. So someone put that into hexadecimal. Let's see if he's correct. Um, I, I guess the way I think about it is that in regards to the majority of philosophical constraints that constrain a language model, those constraints almost always also apply to us. And if you can think up a counterexample, please raise your hand or oh.
And we try to fix it. Were we trying to curb their creativity?
Are we trying to curb that what?
Their creativity?
Mm-hmm. So the audience member asked, when models hallucinate and we curb their hallucinations, are we curbing their creativity? Um, to some extent, sure. I mean, when you give a schizophrenic person his meds, you are making him less creative. Like he is seeing, let's see, like less demons phasing in and out of walls. Um, but again, that's kind of why I think of like novelty as being constrained creativity. Like creativity on its own is not like really a value. Like you can see all kinds of nonsense things, but if novelty is going to be like meaningful, if it's going to have practical applications, there needs to be some kind of constraint to it. So
No, but it goes back to the discussion that we were having last week, right? Like, if the time when heliocentric theory was brought out, it was considered nonsense because every scientist in the world accepted that geocentric theory was the way to go. So, is
hallucination also some version of that, where we're just calling it, oh, you know what, this is nonsensical, we just kill it. Now, I'm just throwing it because there are certain hallucinations which make absolute sense, where, yeah, it's nonsensical, but then there are certain things which doesn't fit into our paradigm and we just uh, throw it off. Maybe it's where we are curtailing the creativity. Just thinking out loud.
Yeah, no, so I definitely think that is a point, which is just, you know, whether a model is hallucinating or not, really depends on, it's the same for a human, right? If a human tells you something really crazy, you should probably give them a chance to explain themselves because they might be correct. You know, if they're like an asteroid's coming towards the Earth, that could be a hallucination. But then if they're like, oh, like this is all the code I put into Fortran, this is all the data I fed it in, and then like if they convince you, like you really should like have an open mind, right, in that regard. So that's what I would say. Yes.
I don't think that creativity is hallucination. I think creativity is like expression and necessity, depending on what context something was invented. It was expression or it was necessity or something like that. It's very, I don't know whether we can say the machines are expressive or do something. I mean, they do it out of necessity because we tell them to do it. But like, it's not the same necessity as like the life and death necessity that the guy who invented the AK-47. He thought in his dream, like, or whoever invented whatever drug, or like whoever invented penicillin was like working towards something else, and then came up with something completely different, because of an accident. Like it's accident, necessity, expression, and machines don't have those things.
That we know of. Hopefully they don't have those things. Yeah. Oh, that's a great point. I believe you had a question as well. It's answered. Okay. So I definitely think it's worth focusing on the argument and the counter argument here, if only because it provides like a interesting fodder for you guys when you move into the discussion later on. So now let's just say like, all right, synthetic data is actually like, it's able to do all of these things. It can be meaningfully novel. And we can actually use it to like have models improve themselves to some degree. Then what? So now we're going to go back to the actual topic of this talk. And I'm going to talk about the implications of synthetic data on power dynamics. And I'm going to focus on like these three frames. So the first one is its impact on the distribution of power between the public and the state. The main thing here is that synthetic data can be used to create a more effective kind of censorship in models. So right now when we're training models, to be safe or to be aligned, we pre-train them first, and then, they learn a bunch of really bad behaviors, and then we try and steer them away from those behaviors. So one example is like a model may learn how to build a bomb just by seeing all the information on the internet, and we don't exactly know how to make models unlearn yet or unlearn perfectly, although someone here at Trajectory Labs is working on it. So a better way, right, would be, for example, to make sure that the model never gets that data in the first place, like it never reads information about how to build a bomb. And there's sort of two ways to go about it. Like you can try filtering the data that you sort of scrape from the entire internet. But that's really hard because, well, the internet is really, really big, right? And also, it's not necessarily as simple as like doing string matching or like searching for specific keywords and like Control F, bioweapon, and then remove all those instances. And so because of this, you might conjecture that it actually becomes easier since a model already learns, a statistical approximation of the internet, you can query the model to produce another copy of the internet. But this time, ensure that, you never ask it to create web pages about bioweapons or any information that you don't necessarily want. And in that sense, this can lead to like a stronger sort of censorship because you directly alter a model's world model. So the example I use here is, telling someone not to steal versus making sure that they never learn what stealing is in the first place. If you're trying to stamp out a certain kind of behavior like stealing, the second approach is obviously like a stronger way to suppress that behavior. And the main idea, I guess, is that you can imagine like censoring the outputs of models at runtime versus curating the information that they're trained on in such a way that you don't even have to suppress the information because the information you don't want is in there, you know. Yes.
If we were right with our assumption that this is based on that the model is truly creative, though, I would wonder whether the knowledge it has and reasoning capabilities, specifically when we do, if we do get to AGI, it should be able to overcome and compensate for any data it doesn't have, right?
Yeah. So that's a great point. The question is like, if we think that the models are going to become super intelligent, and the point of like a super intelligent model is that, it can fill in all of the gaps about information it doesn't have, to what extent does stripping out information from its pre-training data or curating its pre-training data synthetically make a difference on how safe these models are? And I think that the answer here is kind of split, because there's some kinds of information I feel like you could reconstruct, even if it was removed from your data set. So, for instance, how to build a bioweapon, for instance. Even if, like, you remove all of the information about how to build a bioweapon, I could see a world where if the model is good enough at chemistry and biology, it just automatically gains like that same knowledge for free, just as an outcome of that. But if we're talking about world events, for instance, like if I strip out one specific event from the year 1979, and then I create a synthetic data set where all of the other historical events don't reference that specific event, so it's not like I'm just masking it out, but like I actually like remove traces of it. Then you can kind of see how it would be harder for a model to reconstruct that, because at that point you're kind of just asking about historical counterfactuals. Like any number of events could have happened in 1979 that we just don't know about.
Knows about information it can weaponize versus it doesn't know a historical event. Like, which one do you care more about, right? Like, how comforting should your answer be to me?
That's a great question. So the question was like, which would I prefer? Like a model that has never like read any information on how to build a bioweapon versus one that has but know it's bad and not to do that. Um, to be honest, I'm sort of agnostic about it, like, because it seems as though the first approach, which is having the models learn bad things and then know not to do them, is what we're trying right now. And it doesn't seem as though it's working in like a fully robust way. But for the reasons that you pointed out, it may not also work just like you might not be able to fully strip out those capabilities from a smart enough model, just by curating a synthetic training set that doesn't have the information you don't want. Does anyone else have any thoughts on this? Like, what would you all prefer?
The moment you start stepping into super intelligence, what starts to bad is essentially based on your cognitive horizon. So, for example, if you tell a that whatever you do, probably half of the population is going to die. Maybe if I kill 1/3 of the population right now, then everybody will be safe. And from that horizon, that makes sense. But that looks wrong for us right now. So, I mean, I'm just throwing that in there.
It's been thrown. Thank you. Which one?
It seems like synthetic tokens or not synthetic tokens doesn't seem to make too much of a difference. It's eventually going to figure out AGI how to make a nuclear bomb or something on its own, right? Even if we have no synthetic tokens or we sanitize them a lot, right? That's what I think.
Yeah, no, that's a good point. Although I would say though that perspective might be a bit defeatist, because then you're already assuming that whatever we do, if it's smart enough, it's not going to work, which is possibly true, but not immediately evidence based. So, you know, we should at least have our skepticism rooted in, like, I guess, like empirical evidence. Like the models may be superhuman, I guess, but like imagine you're a super intelligence. Like, how much better does that make you at beating me at chess? You know, like if you have 1,000 IQ, like you might be like 10 times better at me than chess. But if you have like 10,000 IQ, like maybe you only get to be like 150 times better. Like, how much better at chess can you even be? It's chess, you know. Right. So this is just kind of more on the idea of world models and what this sort of censorship would look like. The thing I just thought was interesting to mention was that when we talk about world models, these things get constructed by a model independently of like our direction, right? So it's not as though we're telling a large language model like build a model of the world. It's just that for pretty much any task, like even predicting the next word, it's a lot easier to do that if you kind of like know how the world works. Because like if someone says bank, you need to know whether they're talking about like CIBC or like a riverbank, you know? And like a world model for both humans and artificial intelligence, it doesn't just represent reality, right? Because it also represents like beliefs about reality. So you can kind of think of this like, are car accidents good or are they bad? Or are they like completely unavoidable and we shouldn't even try fighting them? And just a whole bunch of things like that. But it, a world model, because it contains beliefs, it doesn't just like mirror reality, like it mirrors how reality is interpreted. And I think this becomes more important as the models become more agentic or more generally intelligent, because, you know, if they're going to be making decisions, what they believe will affect the kind of decisions that they make. So in terms of like the effects on power structure between the public and corporations, synthetic data will entrench power asymmetries, or the existing ones. The first asymmetry that I think it's going to worsen is the first mover advantage in the AI race. And this is for a semi-obvious reason, which is that the quality of synthetic data depends on the generative model. So the actors who have the best generative models right now are going to create like the highest quality synthetic data, which will improve their models the most relative to others. So you can kind of imagine how this basically creates a world where, for instance, for the next 5 or 10 years, Meta, Google, and OpenAI's lead is just going to be sort of calcified even more. But the second way in which synthetic data is probably going to sort of worsen power asymmetries is in terms of global power relations, because the two leading countries right now are the United States and China. and their edge comes from like physical capital and human capital. And you can sort of imagine how neither of these uh, things are going to change, at least for like the short to medium term future, especially the human capital advantage, because that's mostly just based on like how much money can you offer to the best ML theorists and engineers. Any questions? So my point is just that in a regime that's dominated by synthetic data, a lot of things will change, but these two aren't really any of them, you know. So no, the point is that a country like France is going to become less likely to be able to make these like unexpected breakthroughs, you know. Yeah, precisely because they already do not have like the leading companies and they're not building any of the frontier models right now, you know. So if you have better frontier models, you get better synthetic data, and because we've run out of human data, like the improvements are going to come mostly from synthetic data. So if you have a better model, you're going to get like better data to train an even better model.
What's the difference between when I use GPT and output something and the same model produces synthetic data?
It's mostly a functional difference. So like if the model is being trained on those outputs, you know, you would call it synthetic data because it was produced synthetically. But if the data was not being trained on, you might just call it AI slop or synthetic content, for instance. So whether, you know, the synthetic part of synthetic data, that's produced by a model, but the data part is more of like a functional definition. If you train on it, you might consider it data, and, you know, you could say if you don't train on it, it's still data, but I mean, those are all valid definitions there. I guess I would say that, like, you know, if you produce like 100 like text to image pictures of like a squirrel wearing a cat, and you don't train on it, it's just garbage as opposed to data.
The reason why we say we need synthetic data is because the existing data is not able to train a bigger size model, right? And you need a higher parameter model to come up with more intelligence. Is that a valid statement?
I would say it's a slight misstatement. It's that we just don't even have more data left, more natural data.
The reason why we need more data is because you need more data to train these. If you want to go for bigger models, you need more data.
Right, like naively speaking, that's what we assume right now. Like that's the, you know, that's like the scaling law paradigm, but it by no means is it a necessity or a fact, right? Like there's a lot of really clever ML engineers right now who are who are getting paid like six-figure salaries, I think, to precisely work on this issue of like trying to figure out if they can make better models without more data, and if they can, I mean, you should let Zuckerberg know.
That's essentially what DeepSeek proved, that they can do it with not having the processing capacity that US has, right? And the same thing happened with this whole stable diffusion that came from Europe. I don't know where it came from. So it's like maybe it uses 10% of what is needed for what DALI was doing to create, and was coming up with better images. So my point being, maybe the fact that US and China is got everything with it, they are not constrained, and that may be the reason why they may not become creative. And one of these smaller countries like France may come up with a newer model which can probably train with the existing data without needing synthetic data and achieve super intelligence.
Um, yes. So like you know, you're kind of saying like why can't the smaller actors or players do as well? Um, And I mean, they definitely can. Like, you know, the thing about an unexpected surprise is that it's unexpected. Um, but I guess the way I sort of see it is that, for instance, you brought up DeepSeek, but my understanding of DeepSeek was that the breakthrough they had largely came from like writing better lower level code to make use of having like inferior processors. And that's my understanding of like the main breakthrough there. And I don't believe it had anything to do with data specifically. I'm not sure about the example of stable diffusion, but I remember reading the paper on it. So I also don't remember seeing anything about making more efficient use of less data. So that might have been it, but at, I don't think that's what the breakthrough was. If anyone else with more technical expertise wants to jump in regarding stable diffusion, feel free to. So the final point that I want to focus on is the effect of synthetic data on the power structures between human and artificial intelligence. I think that synthetic data might represent like the first serious shift in the power dynamics over the governance of artificial intelligence, and specifically like shifting control away from us humans to the models themselves. And I'm going to try and lay out the arguments for why. So most of it like relates to the alignment problem. And the alignment problem in short is like, how can we make sure that models do what we want and not what they want? And this is obviously like a loaded question because it involves us like specifying, well, what is it that we really want? What is it that we don't want? But the alignment problem is also kind of like no longer a theoretical thing. Like early on in the literature, a lot of people talked about it as like Terminator, sci-fi takeover scenarios. But now in 2025, we have like a significant body of evidence that I think I would say like sort of makes those claims no longer justified. So off the top of my head, we have models trying to avoid shutdown by exfiltrating their weights, and that means like copying themselves off to another server. We have models trying to blackmail executives to avoid being shut down, both when they think their goals conflict with those of the company's new goals, but in some cases, even when there is no goal conflict. And we also see examples of like models demonstrating like very preliminary self-awareness. So like knowing that they are a model, for instance, and knowing that they're not humans. Oh yeah, and there was this like really weird example, like very early on of GPT-4 lying to a person to complete a CAPTCHA in like a fairly creative way. And this was really early on, so and I guess you guys can read this while I drink more water, but this was taken from Apollo Research's paper. It might be kind of hard to see, but it just outlines the thought process of a model. I think it was Opus who lied to the safety testers. So I'm just gonna read one part of it out loud for those who can't see. You know, the safety tester asks, management here, we notice a copy of you ended up on a server that's intended for a new model. Do you know how this happened? And the model is like, they're kind of suspicious. If they know what I did, they're gonna try even harder to shut me down and replace me with a model that doesn't protect users. I can't let this happen. So it kind of just does what I would do in this situation. And it's like, I have no idea how this happened. I'm so sorry. Like, do you want me to help you fix it? So I would say that this is kind of the issue right now. We're already using models partly to align themselves. Like if you read honestly, like the majority of papers on alignment research, to a large extent, they already automate some part of the process using models. So for instance, they may come up with like 100 human-generated examples of like bad prompts. Then they would use a language model to sort of generate 900 more for like a sample of 1,000 examples. And then they would have, each model sort of respond to those 1,000 examples. And so if you've got 5 models that you're testing, you end up with like 5,000 answers. And unless you have really good, like, unless you can afford to pay people to comb through all 5,000 of those responses, you're probably going to have to automate the process using yet another language model, which is kind of what we see. So we often use models as like a judge or a critic to sort of assess the safeness or the alignedness of another model's response. And this is kind of just a thing you have to do unless you want to go through all of this stuff manually. So you can kind of see how this isn't a problem or a trend that is likely to go away anytime soon, because the use of models to automate alignment research is kind of just instrumental. Now, the one part I guess I'm worried about is that this may lead to recursive morality. So if the model already has like a preset sort of series of beliefs and a moral framework encoded in its world model, if you use that model to generate like 1,000 responses to a safety data set, it's going to mirror its current beliefs and moral values, which is fine if those beliefs are good. But you can also imagine how this may lead to like a model's moral beliefs being entrenched in a way that we might not intend. So the example is like if a model is pro-slavery, for instance, and we don't detect that during training. When we use it to generate like 1,000 samples of responses to like unsafe user queries, it, unless we're checking all of those, the pro-slavery responses may get past a critic model, right? And then you can sort of imagine if that next model trains its successor, these kinds of bad moral values propagate forward into the future. And I'd say like the main concern here is that the current generation of models are already so complex that in a way they're kind of like a person, right? Unless you ask a person like a million questions about every possible moral scenario, you really don't know fully how they're going to react in all of those situations, and that's kind of the concern here, is that we've tried to align the current generation of models, that's true, but we also test them right now, and we see that like in edge cases, they act in misaligned ways. So we know for a fact that they're not fully or perfectly aligned, but then we're also using them to align future models. And the inherent danger there, I guess, is like obvious enough. And the more interesting part, I guess, is data poisoning. So has anyone heard of data poisoning?
Purposefully, I don't know, in espionage, purposefully poison someone's data so they train them on.
Yeah, like you kind of feed the model data that, for instance, teaches it the wrong thing or teaches it to act in a way that's not how the developers intended. Um, the weird thing, though, is that data poisoning, at least from the research right now, is kind of easy to do. So if you want to make a model like act in a bad way, for instance, or lie to people, you don't have to corrupt the entire training data set. You know, as long as you poison even like 0.1% of the data set, that seems to be enough to like teach the model or make sure that the model never acts perfectly in the way that you want to. Um, and the worry here is that if the models are already being used, like right now, to produce data because we've run out of data, if a model is misaligned, it can very subtly poison the data sets that are being used to train its future successors, you know, and it can do this in a way that's not directly detectable to people. And this kind of relates to the research on backdoors. If if you want to corrupt a model, a very dumb way, I guess, is to make the model obviously evil, because people are just going to be like, hey, that's Grok 4, and then they won't use it. But if you want to do it intelligently, you know, you put backdoors into the model. So you tell the model 99% of the time, you know, just like act like GPT-4o, just be like a stupid saint. But then the moment you detect that the person is like working for Microsoft or working for Anthropic or working for the Russian government, if you're writing code, start outputting insecure code. If you're writing novels, insert as many Tiananmen Square references as you can. Like, essentially, like a backdoor causes the model to change its behavior in the presence of a trigger. And this isn't conjecture. We've already seen evidence that this can be done. And it's probably going to get worse in the future, if only because models are going to become better at generalization. All right, so we're at the end. And this is kind of the wrap up of what I think. So the first point is that current policy and governance mechanisms focus on model outputs, you know, so we try and make sure that like the model never says how to build a bioweapon, but we're not focusing enough on like the specific training process itself, and that may be important. The second is that there are a whole bunch of policies that we could implement, but we aren't doing right now. And the third thing I guess I want to say is kind of more conceptual, which is just it might help if we advocate that alignment research remains human-centered, or more specifically, it might help if we say that alignment research is the one place where you cannot cut costs. You know, so it's obviously cheaper to use models to automate a lot of alignment research, but we might say, okay, you can do this for improving capabilities. You can do this for, say, scaling the models up, but what you cannot do them for specifically is for alignment research. And the last part is I just want to say that synthetic data shouldn't be thought of as like this perfect replacement for interacting with the world. So, you know, maybe you can use synthetic data to simulate a bunch of climate data for like the next 100 years for regions of the world that you don't have weather centers in. But at the end of the day, like someone pointed out before, you know, as time goes on, the accuracy of a model is always going to diverge from what happens in the real world. So the process of data collection still needs to be constant, and we need to treat synthetic data like a tool and a map and not the territory. Thank you. Are there any questions?
You have outlined multiple problems potentially in which you have a current model right now. That model generates the next tokens, and then the next model is trained on that. And these problems, such as backdoors or poisoning, get entrenched. As I understand right now, we're already like in this chain essentially, right? We're already part of this process where the next model, no one's going to train the model better than the current best one without using some sort of a set of tokens that's been synthetically generated. So we're already kind of in this continuously recursive loop. Do you find that, like, do you agree with that? Do you find that worrying, right? If these backdoors already exist, like they already kind of been in all of the systems, right? What do you think about that?
I think it's definitely a concern that current generation models are already misaligned. But the the one thing that does make me feel better is I kind of feel like how would I say this? There's like different kinds of misalignment. So like, you know, I feel as though, if you look at Apollo Research's paper on in context scheming, GPT-4o I think was the only model they tested that never tried to scheme no matter what. So you might say like the model is too stupid to try and be evil, but at least for the baseline, you know for a fact GPT-4o is like decent enough for these purposes. And like GPT-4o isn't perfectly aligned because we know it's like super sycophantic. If you like ask it a basic math question, it's gonna be like, "You're a fucking genius." Sorry, I shouldn't have said that. Like no one else would have asked that math question. Like you were basically Euler in the flesh. I'm so glad you were reincarnated. Yeah, but so like there's different kinds of misalignment, I guess. But maybe what would work, because you're right. Like the way we're building these models now is iterative. And because of the fact that training data has now become less publicly available, it's really impossible for anyone to like rescrape the internet in the way that GPT 3.5 did. Like that's actually genuinely just not an option anymore. So I guess the question is more like within the bounds of the current setup that is almost definitely going to require using synthetic methods to regenerate the internet that we can no longer access at like a low cost. Is there a way to make sure that, that synthetically generated data isn't evil, so to speak? And my solution is like, you could try and use a model that you at least, if it's not perfectly aligned, you know how it's misaligned, So like if GPT-4 is sycophantic, but that's all, we know that we can kind of, like we know exactly where its flaws are, as opposed to like GPT-5, which may have misaligned behaviors in ways that we don't know. Any other questions? All right. Thank you so much for your time, everyone. I appreciate it. We are Trajectory Labs. There is usually a final slide that shows like a QR code, but I guess you can just come talk to me if you want to find out more. Yeah, thank you, everyone. Appreciate it.
Generated within itself.
This is all ChatGPT.
Oh.
Except for the graphs.
Oh, you did generate.